When I solve these equations, I want you to keep in mind that let's say an equation is saying that they're equal, right? Let's say we have two things equal. 4 is the same thing as 4. I'm going to be saying that you have to balance the equation, and here's the reasoning why, right? If I'm working with an equation, right, we're assuming it's equal, right? 4 equals 4. We're starting off with something that's equal. If I were to take away 2 from one side only, then you're going to see that I'm going to get 2 is equal to 4. It's not true that 2 is equal to 4 anymore. In order to make sure that it's still true, whatever I do to this side, I'm going to do the same thing to this side. And you'll see that as long as I do that, 4 minus 2, I get 2. 4 minus 2, I get 2 again. It's still true that 2 is equal to 2. So whenever you use a property of equality, you're going to see me say do the same thing to both sides to keep it balanced. And this is the basic idea behind that. You got to make sure that you do the same thing to both sides to keep it balanced. Otherwise, like I said before, just so you can kind of see the difference side by side, if I only do something to one side, I'm going to get 2 equal to 4, which is actually incorrect. That's not equal to 4. So when you're solving an equation, we're always going to assume that it's true when we have variables. But, we want to make sure every step we do, it keeps the equation still balanced. So whatever you do to one side, you have to do the same thing to the other side. And just as another note, you can see it doesn't matter from adding, subtracting, multiplying, or dividing. It's still going to hold true. Like if I were to divide 2 to one side only, you'll see here I get 2 equal to 4, which is false. But if I were to take the same equation, right, and if I were to divide both sides by 2, you can see here that I get 2 equals 2, which is true. So as long as you keep doing the same thing to both sides, you're always going to get the same amount in the next step to be true as well. So again, when I say balance the equation, this is the basic idea behind balancing the equation, is to keep the equation balanced, meaning that if you're starting with something that's true, it still remains true in the next step after you do whatever operation you're using. In this first example, I'm going to show you is called the subtraction property of equality. Oops. Yeah, so subtraction property of equality. There are some basic equations you should be able to solve, and there are 5 of which I'm going to show you. So we have one here, 2, 3, 4, and 5. So I'm going to show you. These are pretty much very common ones you're going to come across. And again, these are one-step equations. So I'm going to show you how to approach each one, how to use the properties of equality and how to show that to solve an equation. So in this first one, we're going to use what we call subtraction property of equality. Our goal is always to isolate the variable x, to figure out what's the value of x. So the purpose of this assignment is merely to understand how to show the work, not just to get the answer. But A and B could be any number you could think of. So this is a very common situation. If you're going to solve for x and you have a term on the same side as x that you want to eliminate, what you're going to use in this case is, you can see here we're adding A. Opposite of adding A is subtracting. So what we're going to do is subtract A, because when we subtract A, when we combine a positive A with a negative A, when we combine the opposites, they're going to cancel out. And for equations, you got to balance the equation by doing the same thing to the other side. So I'm going to subtract A to both sides. And now I'm going to simplify. When I combine this, A and negative A, those cancel out. So we're left with just the term x. Bring down my equal sign. And here, I'm just going to write down B minus A, because I don't know what the values are, and I can't combine them, so I'm just going to leave it as that. But in reality, if these were actual numbers, which we'll see in a little bit, you'll see that you could actually subtract them out if they are like terms. In this example, I'm going to show you the addition property of equality. In this case here, similar idea. We have x minus a. We're trying to solve for x. Since we're subtracting a, I ask myself, because I want to get rid of this term here, what is the opposite of subtracting a? Opposite of subtraction is addition, so I'm going to add a. And to keep the equation balanced, I'm going to add a to the other side as well. And now I'm going to simplify. When I combine opposites, negative a and positive a, they cancel each other out. And we're left with the term x equals, and then I'm going to write down b plus a for this one. In this next example, I'm going to show you the division property of equality. In this example, we have some number times x. And again, don't forget, a and b could be any number you could think of. It could be a fraction, decimal, a whole number, integer, positive, negative, doesn't matter. But in this case, a, it's being multiplied with x. Ask yourself, what is the opposite of multiplying by a number a? Well, the opposite of multiplying by a is to divide by a. So I'm going to divide both sides by a. Again, always do the same thing to both sides to balance the equation. And what we're going to do here is anytime we have the same factor in the numerator and denominator, we know that that's just going to cancel out. We're going to be left with 1 and 1, which means we're just left with the term x on this side, 1x equals, and then b divided by a. We're just going to leave it as b over a because we don't have actual numbers, but we know that whatever this is, we would have to simplify it if possible, whatever, depending on what the numbers are for b and a. In this next example, I'm going to show you the multiplication property of equality. In this next example, we have the term x divided by a, and you can see here opposite. Ask yourself, what is the opposite of dividing by a? Opposite of dividing by a is to multiply. So I'm going to multiply by a to both sides here. Always do the same thing to both sides to balance the equation. And now I'm going to simplify. So if I multiply this out, keep in mind, when you have a number, a whole number or whole amount multiplied with a fraction, I can make this into a fraction. I'll put it over 1. So this will be a times x over 1 times a, which is a. And over here we have b times a. And now we have the same factor in the numerator and denominator, so I know that's going to reduce to 1 and 1. And then we're left with just 1x equals b times a. And now I have my final answer for this one. So again, notice that we solve for x. That's all you're going to solve for an equation is to get 1x by itself. And in this last example, just think of this as a special case when you're solving a one-step equation. And in our last example here, we have a fraction of the term x. So in this case, if you have a fraction, think of it like a special case. Here's the way you're going to get 1x. The fastest way to get 1x is this. Let me just rewrite it here. ax over b equals c. I'm going to do something called the reciprocal. Use the reciprocal of this value here. So I'm going to multiply by the reciprocal of b of a over b. So the reciprocal is to switch it around. And you're going to see in a little bit why we do this. And then do the same thing to the other side to balance out the equation. And now you can see here that I'm going to simplify. I have to simplify this side. So if I multiply this across, I'm going to get b times ax over a times b equals, and then again, if I make the c into a fraction, it'd be over 1. C times b is my numerator, and the denominator is 1 times a, which is just a. And now notice we have the same terms here, same factors, b and b. So I could cancel those out, and that becomes 1 and 1. The a, same reasoning. I can make that a 1 and a 1. Right? Same factors is always going to come out to be a value of 1 when you have the numerator and denominator matching. And now you can see when I multiply all the factors up top, we're going to get 1x over 1 equals c times b over a. And again, if you had actual numbers, you'd be able to simplify this, but since we don't know what they are, we just call them a, b, and c. We'll leave that alone. And then x divided by 1 is just x, and then we get c times b over a. And that's our final answer. We got 1x. So notice that if you have a fraction of x, multiply by the reciprocal, and you'll see that the reason why we do that is because you'll see at the end, when you end up multiplying by the reciprocal, you get the same factors in the numerator and denominator, which cancels out. We're left with one whole amount of x, 1x.